So now that we've talked about the one-cell model, let's look at another model of the atmospheric circulation. We call this the multi-cell model, and it's a little bit more close to reality. Just like before, we're going to make some assumptions. Instead of assuming that the Earth is not rotating, now we're going to put the Earth into motion. We're going to say that we have a rotating Earth. Additionally, like before, we're going to assume that we have a uniform body of water on the Earth's surface. Again, that's not a bad assumption since 70% of the Earth is in fact covered by water. What we end up with is a circulation that looks significantly more complex, and this is because of Coriolis force. Because we treat the Earth as a spinning body, we have to account for this deflection of winds, to the right in the northern hemisphere and to the left in the southern hemisphere. You will be expected to know all of these different pressure systems and wind patterns, and while that may seem daunting at first, there's actually only a handful of pressure systems and wind patterns. Additionally, the northern hemisphere and southern hemisphere are almost mirror images of each other. So if you know one hemisphere, you should be able to figure out the other one. Another thing about the patterns that you're looking at on the right is all of those pressure systems and all of those wind systems are surface features. We're only looking at the ground. So our surface pressure systems that we can see is an equatorial low, a subtropical high, a subpolar low, and a polar high. Notice I put stars next to equatorial low and polar high. That's because those are actually truths that we got out of the one-cell model. If you go back in your notes and look at the one-cell model, those two features at the surface did in fact exist, for the reasons that we actually discussed earlier. That's why we talk about the one-cell model before we discuss this one in detail. Once you have pressure differences, you also have winds, and so between these different pressure systems, we're going to get our surface wind belts. What we end up with is northeasterly and southeasterly trade winds, westerlies, and easterlies. In the next two videos, we're going to dive a little bit deeper into the multi-cell model. We'll talk about how these individual pressure systems and wind belts are actually formed.